This is the second theory lesson on the basics of the low-key cam. Here we are looking at 4 different graphs of displacement for the low-key cam, and these explain 3 different movements of the follower, and the 4th image just is a combination of the 3 different types of movements of the follower. Here we are looking at the graph for the uniform motion of the movement of the follower. As you can see, this graph just has straight lines, and there's a lot that we can deter from this image. And the first thing is that we have our starting point at the baseline of the graph, meaning that that's the minimum displacement. So that's the lowest that the follower can go down, regardless if it's a wedged-ended follower or a roller-ended follower. And then we will see that it then rises for the first 90 degrees, which means there's 3 segments or intervals of 30 degrees where it is constantly rising up to the height of 90 degrees. And then it's dwelling for 60 degrees before it's going to start with a constant increase and rise, and then that will then end up with its maximum displacement at 240 degrees in this example. And then it's a steady decline, a constant decline all the way back to the starting point at 360 degrees, and then it will start again at 0 degrees. So this is just a straightforward uniform motion displacement graph. This graph displays the simple harmonic movement. We immediately notice that we need to do a construction, and we are going to start with the minimum and maximum displacement. Whatever height is provided, we will then halve that height and find the midpoint on the start of the graph. And we will take our compass and draw a light constructions arc that is going to represent our construction. Once we've done that, we're going to use our 30 and 60 degree set square. From the midpoint, draw in 30 and 60 degree intervals so that we know the height displacement at each of these 30 degree intervals. And these intervals must equal the movement on our baseline. So in this case, we know there is 1, 2, 3, 4, 5, 6 intervals from minimum to maximum displacement. Before at 180 degrees, we see then the decline of the follower. Therefore, we know that on our construction on the left, we have to have also the 6 different segment heights. You can do this construction on the right hand side as indicated here, but just make sure that in the second half from 180 degrees to 360 degrees, we also have 6 segments. So therefore, we also have to have 6 segments in our construction on the right, or you could just project the heights from your construction on the left. And in this case, we also see where each of the 30 degree intervals meet with our graph. We have the height displacement that come from our construction at the maximum, and then also at each one of the different heights as I am projecting here. Don't forget the midpoint, and that will then line up sequentially from 0 to the first 30 degrees, the 60 degrees, 90 degrees, 120, 150, and then 180 degrees. And then we will use our French curve if you have one, or do it very, very neat, but preferably a French curve to do this curve that indicates the simple harmonic movement of the follower. This displacement graph shows the movement of the follower in uniform acceleration and retardation, and it's another new construction that you need to do, and I refer to this as how to divide a line into equal segments construction. And what we need to keep in mind here is that our height intervals that we see here must equal the horizontal displacement on our graph. Therefore, we have 6 30-degree intervals from our minimum displacement to our maximum displacement. Those 6 intervals on the x-axis must also equal the height displacement on the y-axis, which is also 6 segments. In order to get that constructions, you can do the construction on both sides or just one of the 2 sides, depending on where you have space. So we will start off by just using this example here. We will take our 60-degree set square, or you can just take any angle for whatever purpose you like, and then from there construct a light construction line at any given angle out to the right like this. And once you've done that, you can use either your compass or a ruler. I normally say just use 5 or 10 millimeters on a ruler and carefully measure off, or you can use your divider, those 6 segments that you need. So therefore that's the first, second, third, fourth, fifth and 6th segment. And once you have that, this construction most people should know by now, you then are going to then just take from the last one, number 6, your set square, and draw a construction line that's going to go from number 6 to the highest point of the graph. That angle that you have determined there, you're going to use now to draw parallel to that the other 5 heights of your construction. And to do that, you just take your set square and your ruler, you hold it up with the first construction, which you should know by now, and then just parallel to that from every single one of these, go and draw parallel construction line to the angle that you've gotten at number 6. And once you have that, all that you do is you project those heights then to your graph like here, so all the way to the left, right through the whole graph. Once you've done all of that, you can then go and then measure off the reference points. But to get there, before we do the reference points, we saw that here was a line right through the middle at 180 degrees. So the easy way to go about this is to start off by drawing from the minimum displacement a diagonal line that goes all the way to the maximum displacement like that on both sides, both with the acceleration and then the retardation. And that is your medium. So when you go and look at that construction, you must see that that midpoint there and midpoint there always aligns with the middle of your segments here of the movement. Therefore, it will have the first 3 segments here and the second intervals of 3 segments there. So that median line must then meet there in the middle. Once you have that with these heights that we projected from our construction, we see now that on that mid line that we have our first height there, the second one there, the third one is in the middle, then the fourth, the fifth, and the last one. So what we do is we will now just take our ruler and from the starting point draw a construction line to those heights on that line that's in the middle. And then we do the same from the maximum displacement, also project those lines like that. This will give us the intervals that we need of our vertical, which is our y displacement, and our horizontal, which is our x displacement or movement. And then what we do is, if we start here at the left, the very first thing at 30 degrees, then at 60 degrees, where that construction line, in this case this yellow line, cuts our vertical construction lines, we will then plot the reference dots at each of the vertical reference lines all the way to 180 degrees, and we will continue with the process then on our decline, which is the retardation, and then we will continue to do this all the way back to 360 degrees. Once we have those reference points, we will just use our French curve and draw in the curve profile, and that should then give us our uniform acceleration and retardations graph of displacement. In this example, we are looking at the three different displacement graphs combined into one. In the first part, we are looking at the uniform motion, which goes up to here. Then we have the simple harmonic motion, which goes up to there. And then the remainder is the uniform acceleration and retardation. Please keep in mind that we do not need the additional constructions for the uniform motion. However, for the simple harmonic motion, we have to do the extra construction of the half circle, and then in the last part, the uniform acceleration and retardation, we have to also do the segment heights of the line, and that construction is also a must-have. And please remember that the amount of segments on the x and y axes must be unanimous. In other words, they must be the same. And that concludes the three different movements of the follower. Here we are looking at an example of the full construction of the displacement graph and the cam disk profile. This is from an old JPEGT grade 11 workbook. And the first thing we focus on is the base of our displacement graph. As we can see that there's a construction line coming from the base of the graph of displacement all the way to the minimum displacement. And in this case, the follower is now at its starting position, also at the minimum displacement. Let's focus now on the graph of displacement. So from 0 degrees to the first 90 degrees, we have a steady rise of the follower. And on our diagram or our construction of the cam disk profile, we see that 30, 60, 90 degree steady rise of the follower. And then from 90 degrees to 150 degrees, we see there it's resting on the graph, and therefore here from 90 to 150 degrees, it's going to have its resting period or dwell. And then from there, it's now going to have a steady rise again all the way to the maximum displacement at 240 degrees. So from 150 degrees, we're now also going to have a rise through 180, 210 to 240 degrees. So there we have the steady rise of the follower all the way to the maximum displacement. And that is why we ask always draw the light construction line all the way around on your cam disk profile so that we can clearly see where the maximum displacement is. And then once it's reached 240 degrees and it's going to fall then all the way back to 360 degrees, and on there we now also see that 270, 300, 330 back to 0 degrees, we have that constant fall all the way back to its starting position, which is then where the whole rotation starts again. Please remember that if we are looking at this cam disk profile, we always will indicate the direction of the turn, but because we are doing the construction as this rotary action happens, we must then label our construction of the cam disk profile in the opposite direction as that of the turn of the camshaft. Let's do a close-up look of the graph of displacement for this uniform motion. So firstly, we also note that we have to add the label for uniform motion. That must be in capital block letters, so always remember to do that label there. And then when we do the scaling of our graph, we must know that we just start anywhere here and draw a line across here, and this baseline must be in line obviously with the minimum displacement. That is a given. It has to be in line with the minimum displacement. And then what we also need to look at is what is the scale. So in this case it's 8 millimeters equal each of the 30-degree intervals. Therefore we will have 8 millimeters between each 30-degree interval of our movement through the whole 360 degrees. Please make sure that you measure those intervals on the baseline 100% correct as 8 millimeters. Maybe the divider would be the best tool to use here. So from 0 to 30, 60 and so on, you will make sure that those are perfectly 8 millimeter spacings, depending on what the scale is given to you in your question. So it doesn't mean it's always going to be 8 millimeters. It can be literally anything that is provided. So you just need to do your construction based on the information that has been provided to you. The next thing that we also look at here is that we have to indicate the heading for the displacement graph, also capital block letters, or as people refer to it, it must be printed and obviously written with pencil, not with anything other than a pencil. And then we have to indicate the degree intervals at each one of these 30-degree segments all across the baseline. And you have to draw these vertical construction lines above those 30-degree intervals, and they must be drawn at the height of your maximum displacement. Therefore, you need to go through your question, make sure what is the distance from the minimum displacement to the maximum displacement, and that is known or described as the actual displacement of the follower. In other words, how far did the follower rise through each of the 30-degree intervals till it reached its maximum displacement and then back to the minimum displacement. So this is crucial to understand these terms and know what we are talking about. And then what we also need to make sure is that when we do our reference points, I always ask the students to make small little reference dots at each one of these intervals, because that just helps me to see if there is a mistake, where that mistake happened, but it always just brings up the construction and show us the correct height of displacement of the follower at each of the individual segments. We can also find that there will be 45 degrees, for example, where we now have between 30 and 60 degrees, a 15-degree interval. So, but those are the only alternatives that we work with. Like we have mentioned in the previous video, only 30 or 15-degree intervals may be used in our examples. Here we are going to illustrate the use of the 15-degree interval, where we start with our follower at the maximum displacement and it's going to fall all the way to the starting position at 360 degrees to complete its full rotation. So let's say between 270 degrees and 300 degrees, we want to show now an extra 15-degree interval on our cam disk profiles construction. Therefore, we start with the graph of displacement and we will then, between 270 degrees and 300 degrees, take the 285 degrees, label it, and then we must also draw in a light construction line that is right in the middle between 270 and 300 degrees to indicate that 15-degree interval. Where it now cuts our graph of displacement, it creates a reference point, and that reference point is what we will now project all the way to our vertical center line of our cam disk profile. Please remember that all of these heights that are projected must always go to the vertical center line of our cam profile, and that we have to then measure these off at each one of the segments where it actually cuts on our graph of displacement. So each one of these reference points must be projected to the vertical center line of our cam profiles construction. So some of these reference points, when we project them, will go very close to previously projected lines. So we must make sure that we keep those lines apart from one another, and sometimes they do even fall on top of one another. Then you just need to accommodate that. So with this, we now have the 15-degree interval set up, and we are sure that we know that we're going to show this 15-degree interval on our cam disk profiles construction as well. This concludes our second basic theoretical lesson on the loci of a cam. And I would like to thank TurboCAD Africa, EGD Learning, and JPEGD, and the online school for all the good and hard work they do for our subject.